Ever wondered why an AI might act like it knows something for sure, when it's clearly clueless? Or why some explanations from machines feel more trustworthy than others? Today we're cracking open the secret sauce behind AI transparency, uncertainty. It's not just a flaw, it's a roadmap to building smarter, more honest machines. Let's start with a simple truth: AI isn't perfect. It makes predictions based on data, but sometimes it's just unsure. And that uncertainty isn't a bad thing. In fact, researchers are using it to improve how AI explains itself. The key lies in distinguishing two types of uncertainty. First, aleatoric uncertainty, the kind that's unavoidable. Think of it as the noise in the world. Like trying to predict the exact weather tomorrow when the atmosphere is chaotic. Some problems are just messy, and no amount of data will make them perfect. Then there's epistemic uncertainty, the kind that comes from what the model doesn't know. Imagine a student who hasn't studied for a test. They might guess, but their answers aren't reliable. If an AI is in this state, its explanations are basically winging it. Here's the breakthrough. These two types of uncertainty tell us how to explain a prediction. If the AI is unsure because it lacks data epistemic, the research says, don't trust the explanation. It's like a doctor saying, I don't have enough info to diagnose this. But if the uncertainty comes from a noisy dataset, aleatoric, the AI can use counterfactuals. What if the input were different? To clarify its reasoning. And when the AI is pretty sure, low uncertainty. It leans on feature importance, highlighting the key factors that led to the decision. It's like a chef listing the star ingredients in a dish. Why does this matter? Traditional AI explanations often treat every prediction the same. But this approach adapts to the situation. High epistemic uncertainty. Don't trust the explanation. High aleatoric. Use counterfactuals. Low uncertainty. Go with feature importance. It's like a map that changes depending on the terrain. The experiments back this up. In image classification, models with high aleatoric uncertainty, like blurry photos, used counterfactuals to explain decisions, while clear images relied on straightforward analysis. And when models rejected shaky explanations in uncertain cases, their overall reliability shot up. This isn't just about making AI more transparent, it's about making it trustworthy. By acknowledging uncertainty, we're not hiding flaws, we're building a system that's honest about its limits. And that's a game changer for fields like healthcare, finance, or autonomous systems, where wrong answers can have real consequences. But how do researchers actually measure this? Let's dive into the math. Some use Bayesian statistics, essentially updating beliefs as new data arrives. Others borrow from physics and economics, but the most promising methods involve quantifying uncertainty through techniques like centroid-based uncertainty. Here's how it works. Imagine data points as stars in a galaxy. The model groups them into clusters, centroids, and measures how far a new prediction is from these clusters. The farther it is, the more uncertain the model is. In 2020, researchers even developed a formula to maximize this certainty score, like giving the model a confidence boost. Then there's Shannon entropy, a concept from information theory. It's like measuring how spread out the model's uncertainty is. If it's equally unsure between two answers, that's high entropy. Low entropy means it's more certain. Combining these ideas, studies found that in datasets like breast cancer or Parkinson's, higher uncertainty did correlate with less reliable predictions. But in others like iris or wine, the link was weaker, highlighting that uncertainty isn't one size fits all. What about teamwork? The ensemble-based method uses multiple models, like a team of experts working together. They trained 100 estimators, think of them as individual guessers, and combined their results. When the team disagreed, the model flagged the prediction as uncertain. It's like a group of doctors debating a diagnosis before finalizing a verdict. So next time you see an AI explanation, ask yourself, is this model confident or is it just guessing? The answer might be hiding in the uncertainty. Thanks for watching. If you want to explore how this works in real AI systems, hit subscribe for more deep dives into the science behind the tech. Until next time, stay curious.